Algebra 1, this is Unit 1, Lesson 3. Let's go over the homework. Let's see, for this one, we are looking at this idea of a recursive definition. That's a new vocab word here. And also as we skip on down here, yep, we got constant difference. There's our vocab here. And so writing the rules and everything. Now, I asked you to do just numbers 1 through 4. Numbers 1 through 4. Let's hop into this and see if we should do a little more than that. But so yeah, in class today we had that problem where we had the little machine, and the machine was making up different number rules as we were going along. Recursive, remember, is where we're saying, hey, what is the first term and how does it grow or shrink? So when we look at this, 1/2, 1/4, I'm going to zoom in a little more, 1/2, 1/4, 1/8. Now, there's two ways that we could say with this, that this is a pattern. It's not adding by the same amount. This is a pattern that is either cutting these numbers in half, dividing by 2, or multiplying by another 1/2. A half times a half is a fourth times a half is an eighth times a half is a 16th. So what are the next three numbers in the sequence? Well, we would have a 16th. And then what's half of a 16th? Well, half of a 16th, the next number, comma there, would be a 32nd. And the next number after that would be a 64th, 1/64th. Again, it's like, what are we really doing with that? We're taking each number, that 1/8, and multiplying it by 1/2, or taking half of it. When we multiply fractions, we do the numerators times each other. 1 times 1 is 1. And then we do the denominators times each other. 8 times 2 is 16. And then we're taking 1/16 and multiplying that by 1/2. 1 times 1 is 1. 2 times 16 is 32. And we're just continuing that pattern on and on and on. Okay. So those are the next three terms. What does our recursive rule look like for this? The recursive rule is where, now they have a kind of like a frame here for it. The definition, the recursive definition is say the pattern starts with 1/2 and then it multiplies by 1/2 each time. Is it okay for you to say that it divides by 2 each time? Yes, it is okay for you to say that. The role model answer is that any of these that have a constant ratio, you say that it multiplies, and any of these that has a constant difference, we say that it is adding. Adding and multiplying are standard operations that we use for these, but it is okay to express it in a mathematically equivalent way. Let's move on to number 3. Complete the recursive definition for each sequence. So what's the first term? What's the constant difference or ratio? Oh, is it a constant difference or ratio? And then what is the rule? So first, this is easy. A 2 is the first, and then a 5, and then a 50, and then a 1/3. Those are all of our first terms, easy enough. When we look at this, we're saying, is it a constant, constant difference or ratio? So constant, I'm just going to do that. Constant what? Constant difference or ratio. Well, let's look. 2, 4, 6, 8. Okay. That's adding 2 each time. So I'm going to write adding 2, a positive 2. I'm going to use a sign for that. That's important. And that means it's a constant difference. Okay. 5, 7, 9, 11. Oh, 5 adds 2 to 7. 7 plus 2 is 9. 9 plus 2 is 11. This is also adding 2 each time. It just has a different starting value. So this is also a constant difference, and it's the same difference of that positive 2 each time. Okay. 50, 25, 0. Now, if this was 50, 25, and then like 12.5, it would be cutting it in half each time, but it jumps to 0. So that means that they're subtracting 25. Subtracting 25 and 0 minus 25. Okay, so they are adding a negative 25. Yes, you could say subtracting positive 25. That's mathematically equivalent. And this is also a constant difference. So we got 3 of these in a row that are constant difference. Let's look at the last one. A third plus 2/3 would make 1. 1 plus 2 makes 3. And 3 plus 6 makes 9. This is not a constant difference. This is a constant ratio. Now, what is the ratio of a third to 1, 1 to 3, 3 to 9? Well, if we take any 2 of those, and we take the number and then the number before it, 9 divided by 3, that is 9 divided by 3, that's equal to 3. take this number and the number before it. 3 divided by 1 is 3. 1 divided by 1/3. How many times does the third go into 1? It goes into it 3 times. That is the constant ratio of 3 over 1. 3 for every 1. This is actually the constant ratio right there. Okay, and so what do we say? We say that it's multiplying by 3 each time. It is tripling each time. That would be mathematically equivalent. Let's move on. The sequence has a constant difference of 5. That means a positive 5. So that means we're adding 5 each time we go in this direction. If we're going in that direction, we're going to be subtracting 5. So 7 minus 5 is 2. 2 minus 5 is negative 3. 7 plus 5 is 12. 12 plus 5 is 17. Done. Okay. Now that's all I asked you to do. If you wanted to check your answers for any of the other ones, we got them posted online. Right there, we'll call it quits though. The big thing is, can you write these recursive rules? What does it start with and how does it grow or decrease? Take care, folks.